Let's be honest, car announcements can get a little snooze-worthy, but trust me, this one is different. Ford just unveiled a plan so audacious, so out of the box, it'll make you wonder if they've been peeking into the future. If you've even remotely been interested in cars or love a good surprise, then you must watch this video. In this video, we will disclose all the details about Ford's recent announcement. So stay tuned until the end of the video and hit that red subscribe button first. Ford has developed a groundbreaking twin-turbo system that's so advanced it might make your head spin. You might wonder why Ford, known for its mass-produced EcoBoost V6 engines, would go through the trouble and expense of making a twin-turbo system. Well, there's a good reason behind it. In older EcoBoost engines, Ford used smaller turbos. These small turbos had the advantage of spinning up quickly because they were lightweight. When you hit the gas, you didn't experience that annoying turbo lag, the delay before the power kicks in. The smaller turbos were great for quick boosts and faster response times. However, because of their size, these small turbos couldn't push enough air at higher speeds. They couldn't keep up, leaving the engine starved for air when you needed it the most. Ford's new system combines a big and small turbo to solve this. This setup isn't entirely new in the automotive world, but Ford has refined it to a new level. The smaller turbo handles the low speed, quick response needs, getting you moving without lag. Then as the engine speed climbs, the larger turbo kicks in, providing the necessary airflow for high-speed performance. This dual turbo system ensures you get the best of both worlds: immediate power when you hit the accelerator and sustained performance at higher speeds. Sure, twin-turbo setups have been done before, but Ford's new system is on a new level of complexity that could make your head spin. It might seem like a risky move, especially for a company grappling with quality control issues, but here's how it works, and trust me, it's intricate. Ford's latest twin-turbo technology, dubbed VGT turbos, alters the engine's intake valve timing to create a Miller combustion cycle. The cycle is clever. The intake valves stay open during the first part of the compression stroke, which means some air-fuel mixture gets pushed back into the intake manifold before the valves close. Why do this? Well, it allows the engine to have an expansion ratio larger than the compression ratio. This tweak significantly boosts the engine's thermal efficiency, making it run cooler and more efficiently. Lower exhaust gas temperatures are another benefit, which is great for performance and longevity. Moreover, Ford's new turbo system is edging towards rocket ship level complexity, and let's be honest, this kind of technology is bound to break at some point. When it does, fixing it will be a nightmare. Few people will know how to repair these things, and it'll be a pricey affair, much like dealing with BMW's dual turbos on their straight 6 engines. Those are integrated into the exhaust manifold, so you must replace the whole assembly when they fail. It costs a small fortune to fix. Porsche has also delved into complex turbo systems. They have a setup where electric turbos work alongside traditional ones, using electric motors and exhaust gases to boost performance. It's a marvel of engineering, but comes with a hefty price tag. Porsche can get away with it because their customers expect high costs for top-notch performance. Ford has patented this intricate system and plans to put it in their regular mass-produced cars. But repairing these things will be expensive when they break, and they will. All this effort to combat some turbo lag seems over the top. For most drivers, dealing with such a complex and costly repair might be off-putting. Ford's aim to reduce turbo lag with this advanced technology could lead to higher maintenance costs and headaches. While seeing this kind of innovation is exciting, the practical implications might make potential buyers think twice. These engineers and designers are living in an ivory tower. People just want cars that run well without all this overly complex stuff that's bound to break and cost a fortune to fix. It's frustrating because when these systems do break, it often happens right after the warranty expires. It is a deliberate strategy to avoid making vehicles that last 200,000 or 300,000 miles. Instead, they seem to be designing cars that break down after the warranty, pushing people to buy new ones. Take this new turbo system for example. Sure, it's cutting-edge technology, but do we need our cars to be as complex as rocket ships? The practical drawbacks are significant. Advanced technology is fascinating, but comes with a high price tag and potential reliability issues. Then there are stories like the one from Bowtie Guy 887. He has flood damage on his 2012 Silverado 1500 after driving through water that reached the top of the tires. Despite trying to get out in a 4-wheel drive, the water eventually filled his cup holders and reached midway up the dashboard. To make matters worse, he found out he only has liability insurance, even though he paid $300 monthly. Situations like this highlight the real-world challenges and frustrations of maintaining and repairing vehicles, especially when dealing with advanced expensive technologies. Years ago, fixing cars was a lot simpler. They had carburetors and distributors, nothing too complicated. You could replace the ignition system or the carburetor if something goes wrong. Carburetors were just metal parts spraying fuel, so if they got wet, you could take them out, dry them off, and they'd work fine again. there weren't any electronic components to worry about. But nowadays, you can say goodbye if your car gets flooded up to the dashboard. Modern cars are packed with electronics. Once those electronics get submerged, they're usually ruined. Unlike when you could dry things out and return them on the road, today's vehicles rely on complex computer systems, and water damage to these systems is often irreparable. On another note, there's a debate about whether leasing a vehicle is a good way to handle negative equity. Some people think trading in a leased car is a good strategy, but economically, leasing can be one of the worst decisions if you run a business and can write it off as a business expense. When you lease a car, you're renting it long term. You make payments for the lease term, but you don't own the vehicle at the end. It's just a continuous cycle of paying without building any equity. In the long run, leasing means you're always making payments. You never get to the point where you own the car outright. It's like having a permanent car payment, which can be financially draining. If you lease, you're committed to always having the monthly expense, which adds up over time. Leasing cars is one of the dumbest things you can do unless you can write it off as a business expense. That's the only scenario where leasing makes any financial sense. There's another exception though. Let's say you've always dreamed of driving a Jaguar. In that case, leasing one for a couple of years might make sense. You can enjoy the car, get it out of your system, and then move on to something more reliable and cost-effective. For most people, however, leasing could be a better financial decision. You're throwing money away without ever building any equity in the vehicle. It's just a constant cycle of payments without ever owning anything. Now, switching gears, let's talk about that humming noise under your car at low speeds. Lorenzo868 mentioned experiencing this issue, which goes away at around 35 to 40 miles per hour. Many might suspect a wheel bearing, but in this case, it's unlikely. Wheel bearings typically make a humming noise that gets louder and more persistent as you speed up. Instead, the problem is probably with your tires. Tires can make a humming noise if they're out of round or slightly worn. This irregularity causes the noise at lower speeds, but as you speed up, the tire shape evens out due to the centrifugal force, and the humming disappears. If it were a wheel bearing, the noise would only get louder and more pronounced with speed. Mario Beck has a 2010 Toyota Matrix with a clicking noise from the left tire when turning. He changed both CV joints 3 years ago. So what's the problem? Clicking when you turn is a classic sign of a CV joint issue. Check under the car to see if the rubber boot is ripped. If it is, the grease has probably leaked out, causing the joint to wear out. In that case, you'll need to replace it again. These days, people don't usually replace just the joint. You can buy a new axle, which the Chinese manufacturers build decently for around $70 to $80 at discount auto parts stores. It's easier and often more reliable to replace the entire axle rather than just the joint. Rubio mentioned at 06 Suburban with a P301 code, which indicates a misfire in cylinder 1, and a P300 code indicating random misfires. You've replaced the spark plug, coil pack, and wire, but the problem persists. Misfires don't just happen because of ignition issues. Fuel delivery problems can also cause them. Now with that said, let's wrap up our video today. Share your valuable thoughts on this with us in the comment section below, and don't forget to subscribe. See you in the next video.